Hey guys, welcome to another stream by Azure Developer Community. This is Varun Bansal, the host of the stream, and today we have with us Agam Arora sir, who will be taking the boot camp ahead, which is going to be a 3 days boot camp most probably, followed by a quiz. So Agam Arora sir is a cloud engineer and highly, specialized in the field of cloud computing. So I hope he's going to be the one of the, most experienced mentor to teach us about this cloud computing bootcamp. So without any delay, let's start with the session, and I hope it's going to be a insightful session for you all. So over to you, sir.
Thanks a lot, Varun. Thank you for the introduction. So, welcome, guys. Welcome to the stream for Azure Developer Community. Uh, I welcome you all here. So, today we are just going to discuss about the AZ-900 session, which is the Azure Fundamentals certification. Uh, this is for everyone who is just starting off with the cloud environment and getting to learn things specifically to Azure. So let me first of all uh, share my introduction. So I'm currently a senior system engineer at Infosys. My primary domain is Azure, working on IaaS services, which is infrastructure as a service and infra setup. And my current skill set is visible to you all, guys. So, and I have 3 years of experience in cloud domain itself. I started right off the bat in cloud technologies, and I have done certifications, which is Azure and AWS both. And my particular expertise is in setting up the infrastructure and platform as a service on Azure and AWS. And I also work in close coordination with all the senior engineers to cater to the cloud infrastructure and architecting the cloud native setups. All right. So first of all, before jumping directly into the cloud, we are going to discuss that what is the history of it, why cloud computing came into place, and what was the need of it, what was the demand. So before cloud was very in mainstream, so people used to back in the 90s and early 2000s. So people used to rely, if we talk about infrastructure, people used to rely on uh, other IT vendors or third-party integration services to set up their web hosting or databases or any other services which required the internet, and they enabled to run their applications or services or whatever. So back in the 90s and early 2000s, what used to do is that people used to generally web hosting and application hosting was the main forte of the IT services companies. What they used to do is they used to either use the data center facility, or they used to have some specifically they used to hire some third party co-location service where they can host or enable their web hosting capability. So this is slide which you are seeing is a typical scenario or architecture inside a data center. So what is it exactly? So it is a facility which is run by an organization where you can uh, run your applications, databases, other services like servers, networking, storage, all that facility. So, and all this is done in exchange of the in exchange of money, and these guys deliver the services to you. So this is a backbone of how things used to happen. So in the initial days, this was the architecture. So for example, if there is a company, they want some services, and so let's see. the all the facility in the facility, what used to be available is the CCTV footage and the UPS and generators, staging room, NOC, security, and there used to be an proper entrance and exit. And uh, still this system is prevalent, but of course people have switched to cloud. But this is the system which directly from where the people used to get the services from. So what are the main components which used to be? So one is the networking, which is the network core components like servers, like the switches and routing features. And there used to be servers, lots and lots of servers like 100, 200, or even maybe even more. And storage facilities like NAS and these type of storage, and all these components were used to cater to the hosting of applications and services which were used by the IT companies. And eventually this kept on increasing to, let's say, the manufacturing sector, healthcare sector, and fintech. And this graph kept on going in the J curve side. So these were the main components. And so when we look into, when we focus our lens a bit more uh, in this segment, so the servers where the application would be running would be high configuration, low configuration. We could choose from a lot of options. And in the storage also, we had SDDs, SSDs, and according to the network architecture which the company required, they used to have the switch router and all that. Similar to data centers, there used to be in-house facilities available to the customers, or let's say they would use to do is, for example, if it's a small setup, anybody could set up a single server rack inside their own office or facility, whichever they had. And they used to first of all get some uh, get the proper infrastructure setup, which is would be like a mini data center. Okay. So for example, if there is a company which is a, for example, it's let's take an example of hospital. So in that, there used to be a single room which would be allocated with a single mini data center, where they used to have this type of racks, as we can see on the screen in the server. And along with that, there would be some network core components and the hospital information system, or any application which the hospital required used to run on it. And for example, if it's a billing management system or patient management system, or any other thing which is required by that special hospital. And there used to be one IT administrator which used to manage all these systems. Similar to this hospital example we discussed, uh, all other companies also used to have the system. Like for example, in manufacturing sector, we used to have some ERP software running on the in-house data center or the server. And along with that, we used to have the networking components like routers, switches, and also the storage components. So all these were the core components. But eventually, as the uh, once the inclination towards the IT expenditure increased of the in the industry. So people had software for everything. Like initially, it was just for a single system, but their dependency on the IT software or application increased. So they had to also increase the server components, right? And once that increased, so they had to increase down to the either take a service from third party data center to run the application on the server, or they needed to increase their server room capacity and get more servers in and run it there itself. But this costed a lot more. So that's where cloud computing was introduced. And what it is, we'll discuss in the later slides. So generally, cloud computing is what it's a uh, pool of services which we can use to cater to the customer demand. For example, and all this is on the on demand basis, or let's say which is done in a very quick fashion. So currently we have three major cloud public providers. Other options we do also do have, but these are the three major options, which is AWS and Azure and Google Cloud. So AWS is nothing but it's a Amazon Web Services, uh, and Azure is presented by the Microsoft, and GCP is presented by the Google Cloud. So now we'll discuss in the backstage that what is the uh, s- how data center works with respect to cloud, and how services are delivered from a data center which is centric to delivering the cloud services itself. So Microsoft Microsoft has their 60 plus regions worldwide, which have this type of facility where they have their existing physical space, which you can see in the below these switches in the black, or let's say gray section, and the green represents the physical network or the components which comprise inside the data center. And along with that they have this layer which is hypervisor. What is a hypervisor? So basically what happens is that in a physical data center, the underlying layer comprises of the physical components itself, like we discussed in the previous slides. But this hypervisor is a layer which virtualizes the existing physical underlying infrastructure, and from there we can create small virtual components. So let's discuss one by one. So as we see there, for example, this is the data center. We have all the components available. These are the physical components. But uh, when we go when we want to virtualize this, so this is a very important and interesting concept, which is a foundation layer of the cloud. So uh, we use this so in a physical machine what happens is that there are a lot of dependencies. For example, there is the backlash is that it's a tightly coupled to physical hardware. Uh, we cannot use different components. We cannot customize this existing machine if it's a physical machine, because we have a specific CPU. We can't increase the CPU cores dynamically, right? We can't increase the memory also, and similarly with the storage and the network components, it's very rigid, and it's very difficult to, or we can say impossible to uh, customize this setup, because it's very tightly coupled scene. So what happens is that if we want to virtualize this, there is a virtualization layer as we discussed in the previous slide. If we virtualize this whole physical component using a hypervisor, then uh, we could create small instances of the same physical setup, which is the underlying components. For example, in the physical setup, which is we have a 8 core CPU, and we can create two instances from the same, which is a divided to 4 core and 4 core respectively. Similarly, in memory we have 16 GB slot. We can virtualize this and create 8 virtual RAM, 8 GB virtual RAM over for PC1, and similarly for the PC2, 8 GB. Similarly, disk, if it's a 1 TB SSD NVMe, we can create the 500 and 500. We can split it. But here what happens is we get a virtual component which is available to the customer, and he eventually has to pay lesser than what he used to do in the data center. So it's a very advantageous situation. We can fully utilize our physical component rather than just wasting the resources or exhausting the resources. So there is an extra level of interaction. We have a lot of customization options available. If we do not want this virtual setup, then we can also delete this and then again create one. So this whole scenario is mirrored in the data center, which provides the cloud services. So I hope everybody is able to understand. I'll just check the comment section. If anybody has a doubt, they can post in the comments. How? Okay, so Rinesh says how virtual machines are built up. Okay, we'll come to that. So Rinesh, to answer your quick query here. So uh, this is a setup which you can see uh, in the underlying components. Can you see the CPU, memory, NIC, and disk? This is the physical components. These are the components which are available in the data center. For example, if we go back to this slide, which is yeah, slide number 5. So here we saw that this server racks and networking and storage, these are the components which are available in huge volume inside the data center. So for example, if we talk about server, there would be 500, 600 servers on. Similarly, networking components would be accordingly the higher number, and the storage components would be like you would have 500 disks available or 600, whatever the customer requires. And this is the whole facility where these physical components are there. So when we come to this virtual machines, so there is a virtualization layer available in this uh, above this physical space, and from there we create the virtual instances of this same physical components which are the underlying. So for example, if it's a CPU, then we have the uh, virtual version of this. So the virtual machine or the virtual server, which we can say, is nothing but it's a same instance which is so it's a copy of this. And what we can call is that the underlying operating system, it doesn't know that it's a physical machine underneath it. It just thinks that it's a physical components itself which are running this operating system. Got it? So we can also run Linux, we can also run Windows, we can also run any other uh, option, like whatever distros we are into, and we can use all these components here. So this is the traditional architecture in the data center, and this is the virtual architecture. So with the help of virtualization layer, we can create separate operating system, and we can run specific applications accordingly. So the advantage here is that in the virtual architecture, that for example, if we have a let's say server of 16 core and 32 gigs of RAM, but we deployed an application over it, and the application just consume just minimum requirements of 8 core CPU, and it can run on the 16 gigs of RAM, right? But so here the server components are underutilized. We wasted money basically. Okay, but if we virtualize this infrastructure, we can create virtual components, and we can run the applications according to the system requirements. So the extra 8 gigs of RAM, sorry, 16 gigs of RAM, and the 8 core CPU was not underutilized. It was rather used to create another application which was used by the same company. So this is how it works. So this is the diagram from which we can very easily understand. So this is the traditional system. and we have hypervisors available like type 1. In hypervisors also we have type 1 and type 2. So generally in data centers we use the type 1 version, so which is the VMware or Hyper-V. These are the two main industry level hypervisors which we use. So here they have taken VMware. So we can create separate OS application, operating system, and run an application on it. So these boxes which you can see, these are the virtual machines only, which you can access through the Azure portal. So these are nothing but they are running somewhere in the data center, which is available worldwide. Maybe it would be in India or US or Europe, but you can access these online by connecting to them through Azure portal. So that's easy. That's how it works. So similarly with the that was the virtual machine, how virtual machine was built. So similar to that, we have storage virtualization where we have a pool of disks available, and from for example, if this A to A B C D are 500 gigs each, and we have like 2 TB in total, so we create a pool of it in the virtual space using that hypervisor, and we from this virtual storage pool we can allot a specific disk size. For example, if someone needs just 256 gigs, okay, 256 GB or 500 GB or whatever. So that's how it similar to virtual machine. The storage virtualization, we could have virtual disks available to the customer. So now we have the virtual networks option. So similar to this, uh, the physical networking components like servers and routers are available in the data center, which are virtualized with the help of hypervisor. And we can create a virtual switch, which could be used to create that virtual machine and uh, assign a IP address to it, or connect it to the internet, and then whatever services we want to use accordingly. So these are the this is a virtual network adapter which is connected to this virtual machine. So it's a nothing but it's a PC, virtual PC where the virtual NAT is connected, and it's connected to a virtual network switch, and this is the physical adapter. Okay, so now let's discuss about the infrastructure as a service. What happens is that in the traditional segment, what used to happen is that in the data center facility, everybody sorry, okay, so everybody used to have this networking storage servers. So let's focus on the leftmost table here, which is the traditional on premises, which means the traditional facility which was in house, or anybody who could use their own facility, or a third party data center services or co-location services. So uh, all these components were managed by the owner himself. Okay, so here we can see that you manage bar is given. So it goes from networking till the application. So everything like storage, servers, virtualization, operating system, to data or applications, everything used to be managed by yourself. But as the cloud services started to be given by the companies like Microsoft Azure, so initially the networking, storage, servers, and virtualization was taken care by the by the vendor, which is the Microsoft Azure, and anything above it, the operating system, middleware, runtime data, and applications was uh, in control of the customer. So what was the difference between this and this? So here the orange components were taken care by uh, the Microsoft Azure, and the customer was in a free state to uh, focus their development part, or creating the application, managing the application, rather than just focusing on where to buy these servers and storage and components, and discussing with the uh, OEMs or vendors or whatever. So uh, there was a free option available to the customer, and this headache was taken care of by the Microsoft Azure in return of the money or the monthly bill. So in cloud, what happens is there is a pay-as-you-go model initially, where whatever resources you use, for example, if you use servers for like 23 days, you'll have to pay uh, just for the 23 days usage, and if it's running 24/7, you'll have to pay accordingly. So just like we consume electricity, these models are economic models of cloud are created. So that's why it is so popular, because you do not have to manage anything, you do not have to buy yourself anything, you just have to consume the services, and based on that, you have to pay to the company. So now we are going to discuss in very brief that how this data center is built. So the data center has this facility of server environment. So now we are jumping into the Azure bit by bit. So this is the center security, which is in every Microsoft data center presented worldwide. So in India, we have three locations, three regions. One is in Pune, and another one is in Mumbai, and the third one is in Chennai as of now. And the next facility is of data center is to be created in Hyderabad. So as of now, in every data center which is present, they have this 24/7 security operations and two-factor authentication with biometrics. So anybody going inside or outside the data center, there is a 24/7 monitoring, and there is a check available. And similarly, they have video surveillance and secure destruction bins, and server environment is very secure. So anybody from any company, if they want to use those cloud services, they are totally assured that their applications would be running in a safe environment, and nobody could touch them, nobody could modify them, because the perimeters of the data center facility are quite uh, interesting, and they are quite in a very let's say a secure manner they have placed it. So now jumping to the core infrastructure available in the Azure. So here we have in storage we have disks, blob storage, and in networking we have these services, compute and management. So these are the basic services which are available to us. If we talk about the IaaS specifically, so initially we need to know, just for AZ-900, it's not quite hectic. We just need to know what are virtual machines and how it works. And similarly, basic services like how virtual network works. We do not need to go deep dive into, the working of express route or the working of a DNS. We just need to know how DNS service in Azure works. And similarly, in management, we do not need to go deep dive into the log analytics workspace, like how logs are generated and event logs are created. All that stuff is not required. We just need to know the basics to get that AZ-900 certification. So here we could see the options available. In storage, we have blobs, files, tables, queues. So basically, what happens is that blob store these are the types of storage available in the Azure. These are the primary options. So let's go one by one. So disks are nothing but the uh, virtual disks which we discussed, like, and these are connected to the servers, or we can what we call is virtual machines. So these are connected to the PCs, virtual PCs or servers, which are available to us in the cloud. Disks have three options generally, like the premium storage, which is SSD, and the standard SSD and the normal SSDs. So we have all options available based on the requirement and dependency of the workload. So if we need a very high performance based application which needs a very good input output IOPS and throughput. So there we would require the premium disk available. Similarly, we could use the standard and the SDDs. So next is the file storage. So this is generally like a files for the document storage, and we have some we have network file server available, like where we want to share a file server option to all the company people, and we could mount this Azure file storage in a shared location, and from there we could find out that this is the option available. And next is the blob storage. This is used generally when we have the facility, we want to store images or videos or anything which is in a graphic format. So this is generally used. Blob storage is used for example, Netflix or any OTT platform. So if we have videos available, next time you log in into any OTT platform like Hotstar or anything, just think about this, that how these videos are stored. These are generally in the blob storage if they are using Azure. And next is the tables. So if you have heard about NoSQL, so if you want in no if you want to store the tables of for the NoSQL, and you want the dynamic scaling available, you have a huge setup for that. We could use this type of storage for storing all the NoSQL tables in a specific format. Similarly, queues, which is reliable queues at scale for the cloud services. So queue storage is nothing but, for example, if you have uh, some services connected, like for example, two applications are talking to each other, and one application wants to communicate to the other one, but still it's processing its some other query first, or it's using its logic. So this the initial conversation which the app one wants to do with app two is going get stored in the queue. So so all these queue storage is used in that specific manner. Okay, so this is the basic hot versus cold, which means we have in the storage facility, in the storage options, we have first of all, let's discuss the hot storage, which means that uh, uh, there are specific storage tiers available in Azure. So this is one of them. So uh, hot tier is generally used when the data which is in active use and it stays for processing, and currently we are currently using that specific format. And cold is used for backup or anything which is old in the archive, or so the difference here is also in the hot tier of the storage is quite pricey than the cold one. And uh, generally it's much more than uh, because the input output, or the uh, is quite higher in hot storage because it's currently being used, and cold is for the generally backups or archive storage. So these now we are seeing the general options available for all the virtual machines. So Azure has specifically designed this in such a manner that we have categories assigned to all of them. So A series is for the entry level. B is burstable. So burstable means that, for example, if we have a very low, a very small, let's say, app which is running on cloud, but at times it requires the CPU utilization jumps to, let's say, above 60-70%. So it requires that burst to just sustain rather than timing out, or going offline. So these are instances which are used. These servers are used for that scenario. Next is the general purpose. These are the D series. These are the most used virtual machines in Azure platform. So what happens is that D series have a lot of a very good range. So range like from two virtual CPUs to let's say 8 to 16, sometimes even 32. So and this is the it lies in the very general format. It's used for the all generally in on the most purposes. And so here we have DV2, DV3. Similarly, uh, we have compute optimized, memory optimized. Memory optimized is used generally in the case of databases, and graphic intensive, which is the N series or let's say NVIDIA series. And we have HPC, which is the high performing computing, and purpose built for SAP HANA, which is the ERP setup for the in memory database, specific to running the SAP software. So this is how the journey of the cloud works. So initially the people used to have this on-premises setup, and after that it went to they go to the infrastructure as service where they just use the initial components like server, storage, and networks, and after that they can based on the requirement they can either go to the cloud native they start their cloud native journey by refactoring the application, or they can jump to PaaS services or the serverless platform. It's a choice. And if they want to completely replace their on setups, they could use the SaaS, which is the software as a service. For example, we have Salesforce, we have Office 365. So these are these come under the software service platform. So, what are the general challenges of the cloud? So, the key customer challenges are like, the lack of resource and expertise, and security, and managing the cloud spend. Similarly, infrastructure for all workloads is sometimes not available. They want a hybrid scenario, and but all these challenges are catered to by the Azure. How? By Because Azure has such an environment which caters to all the general requirements, or rather than let's say exceptional requirements as well. So if the customer is running Active Directory, we have Azure AD Connect, which is a service. Similarly, if customer wants to run a hybrid setup, they want to run some of the components on cloud and some of the components back in the data center, which their own facility. So we could have a combination of this in a hybrid scenario where they could run it in a very easy fashion. So whatever is suitable to them. And security and management concerns are taken care as we discussed in the previous slides, and that how Azure is a very perfect environment uh, with respect to catering to the security and management concerns. And similarly, it's a very cost-effective solution. So we have uh, all the benefits available in Azure environment. This is nothing but the holistic view of all the virtual machines again, which is specified in all the categories. Let's have a look at the comments. Okay, so Rinesh had a question. So Azure provides every segment of services for faster computing, right? Okay, so it's Rinesh, it's not about the just about the faster computing. Of course, we have HPC available, but uh, we have all Azure caters to all set of requirements. Uh, like if we can see on the screen, like We need to first of all understand that what is the type of application we are running. Okay, if it requires a very low and it's a does have minimum requirements like even two core CPU would work on it, then why would we would require the faster computing? You do not need it. It's just a it would be the wastage of resources, or let's say the money, right? So we need to be careful how we want to set up. So we need to first of all understand what is the requirement of the application, what is the how it works, how it couples with the other components in the whole architecture. So then we can understand. Then we need to find out that this is the scenario, and we need to take in consideration every aspect, not just the performance. So okay, bro, when is the exam? Exam, you need to schedule it by yourself first, buddy. You need to check out the links available online. It's very easy. Just go to Microsoft Learn or just search for AZ-900 exam schedule. From there, you can schedule it. Any other questions? Anybody else? It's been 40 minutes and counting. So everybody, I hope everybody is able to understand what we are doing here. I mean, I hope we are not just doing very complex tasks. It's just everybody is able to understand. If you are not able to understand any point, you can let me know in the comments. Okay, all right. Let's continue further. Okay, so this is the networking section of Azure. What happens? You can see the map here. So this is the map of Microsoft Global Network. I hope everybody is able to see this. So Microsoft Global Network comprises of these. You can see the wires on orange and blue. This is the internal Microsoft Global Network, which is interconnecting all the global facilities of Microsoft data centers, and they are all connected with each other. And in networking, we have in the basic services, if we talk about, we have virtual network, load balancer, application gateway, Azure DNS, traffic manager, CDN, which is content delivery network, express route, and network watcher. So networking is a very integral component in the cloud computing, specifically if we talk about the IaaS and the PaaS part. How is it? Why? Let's discuss. So here we can witness that in the Azure components, if we need to connect any virtual machine to the internet, we need the virtual network setup. It's a necessity. If we need to host a website, we need DNS service. If we need to uh, store some photos, images, or videos which are quite heavy in volume, and we need to upload it, for example, as we discussed in the OTT section, right? So we need the CDN. It's a content delivery network service. We need to understand in brief that how all this works, and all these components are interconnected together, wherein we have if we talk about all the geeky stuff, so it's 140 plus edge sites. Edge sites mean like it's a CDN setup where we can host our uh, photos, videos, or whatever. Similarly, we have 33,000 miles of fiber available, and the SDN managed network. Okay, last but not the least, very important, the security and management components. So, generally, we have uh, Azure Key Vault, Azure Backup, Resource Manager, and Site Recovery, and Advisor. All these components are very basic and integral to the Azure environment. So basically, Azure Backup is nothing but you can, as the name suggests, you can back up your files, you can back up your virtual machines or the servers and the data, whatever you require on the cloud. Similarly, in Azure Site Recovery, it's a space if you want to, uh, for example, if your virtual server is not running, and but it's very critical. For example, if it's a banking application, and anybody who's catering to the uh, let's say the services on online banking, right? So if they are currently looking forward to catching up with this option of let's they want to do a transaction at 11 a.m. or 12 p.m. whatever, but if because the server is not working, how will they be able to do it? They'll have to either their transaction would be stopped in between, or so it's a very critical setup, right? So we need something like Azure Site Recovery. What it does is that it creates the replica of your own in setup of the virtual machine, and it if there is a failure of your server in the data center, it redirects all the traffic to the secondary server which is running, which starts running, and all the uh, application is same application is running in the secondary server, so the address can be uh, so the customers can log in and then they can do the transactions easily. They do not need to rely on the initial or the primary server. So this is a very important component which is being used since the COVID-19 struck, and especially by those companies which had especially by those companies which had to cater to this let's say uh, what we call is the disaster management, or whose business was relying on all these web applications like Mintra, or any other shopping websites, Amazon, Flipkart, any banking websites, and so they were in fear that if our application goes down for even like half an hour, they have a very huge financial loss, right? So they need these type of things. Similarly, we have Azure Security Center, which is a one-stop shop for all the security services which we have for the Azure services. If we are using Azure App Services, or let's say virtual machines or anything, we need to uh, if we want to set up a security plane for all of them and manage them all together in one space, we can use this uh, service to prevent, detect, and respond to the threats. So similarly, for the identity and access management, we have Azure Active Directory, which is a cloud-based directory uh, similar to the traditional Active Directory, which is available in the Windows Server. So also we have cost management, which is nothing but which monitors and helps you all to uh, check that which resource is using more uh, or which resource is costing you more money, and which resources is unused, or which resources is helping you to optimize the cost. So all these can be managed in the single plane. uh, Similarly, we have Azure Monitor, which is a real-time data monitoring service where you can monitor everything which is running in the cloud or in your own setup. And we have Azure policy, which is used to help us uh, control and create policies or specific conditions respectively to Azure resources. So if we are having, let's say, n number of options for, uh, you know, creating virtual machines. Let's say we do not set a permission, and if we provide the access to some, let's say, ABC person in our company, and he keeps on creating all the virtual machines, even if they don't not required, if they are running. So but if we set a policy that at a time by single user can create only one virtual machine from this portal, that's it. So once that policy is set, even if that person keeps on trying, the administrator has set a policy, so he would not be able to overutilize the resources, or which will save the cost. And similarly, we can enforce this Azure policy for compliance, let's say PCI DSS, or any HIPAA compliance, or any other major RBI guidelines, that this is the permissions which you need to be set up. This is the admin privileges. This is the user privileges. So similarly, we can enforce those policies on subscription level, resource level. Everything is managed there. So this was the complete overview of the prerequisites in the cloud. Tomorrow we'll be discussing in brief that how what are the main components of Azure 900. We'll discuss the syllabus. We'll discuss everything with respect to it. We just have around 5 to 6 minutes left, so I'll just have a look on the comments. If you have any doubts, you can let me know. Okay, so someone said its session was great. Thank you. Uh, how can we mark? So you can, for the attendance and all this stuff. I'm not catering to this. You can have this discussion with the organizers of this session. They can guide you further.
So yeah, guys, the session was good. I hope that it was an insightful session for you all. And someone was asking regarding the attendance session, so no need to worry about that. I think our major focus, first of all, right now in this session should be about learning. And as far as the attendance is, concerned, we'll send you the attendance link to all those students who have attended these things on the mail. You can fill out from there, and we can proceed with the other things as well. So if you guys have any kind of queries or something, you can kindly please jot it down in the comment section, or else we are good to wrap up with the session. So Rinesh Patil says the session was great. Thank you very much. So I don't think there are any doubts from our audience side. So sir, can we wrap up with the day one session?
Sure, absolutely. I think we are good to go.
Yeah. Thank you very much, sir, for coming out and taking out your time for the community folks.
My
It
pleasure.
was it was really nice, the understanding Azure concepts from you. Looking forward to learn more about the Azure services in the 2 days. And yeah, guys, we'll be having a most probably we'll be having a quiz as well where the winners will be getting Microsoft swags. So do attend that as well. I'll be sharing the Discord link where we'll be having the quiz. So as of now, till then, please take care. Tata. Bye bye.